Okay. Well, I want to do a team update on behalf of that kind of TF Lite too. It's like maybe just one slide, like kind of 5 minutes, just to kind of share, what have we been up to recently, right? With the community. So yeah. So I guess we have this like by way of introduction. TF Lite is a project that kind of started out as and still is kind of these days formerly part of the TensorFlow project. But we kind of want to evolve this to be a multi-framework runtime to run on device, right? And it's got good widespread support for kind of CPUs and GPUs and kind of working to add accelerator support to that as well, right? So that's a couple of lines about the TensorFlow Lite project. So recently we've evolved the TF Lite converter to start accepting stable HLO input, as could be kind of outputted from frameworks in various ways. So that's something where we've started to add that kind of functionality and kind of test pads from kind of different frameworks. And the path there is you go from frameworks to stable HLO into the converter, and from there we generate a kind of TF Lite file which goes into the runtime. And the TF Lite file, we historically had only TF Lite ops, and now we're starting the process of adding stable HLO ops there. And specifically, we haven't taken this step yet, but we want to make that be versioned stable HLO, which will be very useful because TF Lite are kind of serialized artifacts that we intend to be kind of multi-device. And there could be a lot of separation in time between when a model is serialized and when it gets run by an on-device runtime. And the versioning features in particular, are pretty appealing. The versioning features in stable HLO are appealing for that kind of use, right? So we could have version models with kind of broad compatibility across devices is the goal there. So I think that's our kind of update, and our kind of one of our to-dos is to kind of move to versioned HLO from kind of stable HLO. And as we're doing that as well, like one of the discussion topics is one of our kind of proposed discussion topics, I guess, is as we're doing that, we have an internal work stream to kind of define, hey, what do we think the right kind of subset of stable HLO to support on devices? Because maybe not all of our on-device runtime is kind of really focused at inference. So some of the distribution ops, perhaps, and some of the more complex data types as well make perhaps kind of less sense for a kind of an on-device inference-focused runtime. So that's one of the things we're doing, because we would like to have as complete support as possible, and that's one of the things we're kind of looking at. So yeah, and like recently the types of things we've been giving feedback to the kind of stable HLO community in particular, right, is the kind of the primary touch point, because at least in our stack we're not using the full OpenXLA compiler piece. It's really the most relevant kind of touch point with the community here is stable HLO. And so for there, we were kind of giving feedback on versioning. Also, we were following the work to kind of improve kind of quantized types that happened earlier, as well as looking at how dynamic shape support is evolving in stable HLO, because that's important for some frameworks. And finally, one of the things we've just started to do is kind of doing prototypes on composites for kind of better on-device performance. If there's a set of operators that we really that are for models, for very performance critical models, looking at this as a prototype path to kind of achieve good performance in a runtime that doesn't have a strong compiler that's just doing kind of interpretation. So yeah, that's a brief update from, I guess, kind of our team and what we're up to. I have some kind of proposed discussion topic things we could maybe chat about on the next slide as a starting point. But if any other teams that wanted to give a brief overview of their work, or kind of wanted to say a few things about what they've been up to, or kind of pain points or anything like this, that'd be kind of useful, I think. But if not, we can move to discussion. But either one is good at this stage.
So anyone want? I guess a lot of people in this room do work with on device. So does anyone want to give an update on either the usage of Stable Flow, TF Lite, or any update on that? Well, I guess that's not.
Okay. Yeah, so like the sort of things where we're looking at in terms of kind of possible future evolutions, like these are three things. So one is one that I would be interesting to get feedback. I guess we can also in the fullness of time, once our thoughts on this are more evolved, potentially write a kind of RFC or something for this. But one of the things we're kind of wondering about is, would it be interesting to have something like an on-device profile as part of Stable HLO that would, maybe define a set of ops that a like edge inference focused backend should support, right? And yeah, and like we think there could be some value in doing that with the community, particularly if there was, multiple different vendors having implementations. It would make it easier for somebody who's working in a framework or developing a model to kind of check, hey, is the set of things I'm doing in this model, does it kind of meet a first pass test of do I only have kind of operations in this model that are compatible with the edge profile if we add such a thing. But yeah, I was kind of wondering if I don't know if anybody in the room has thoughts on this, or if they've, for folks who are already using Stable HLO in backends, if they've already already kind of crossed this bridge and have defined a subset, or have given this any thought. It'd be interesting if anybody else has any thoughts on this to share.
I guess I can say that, like, when we did, TOSA, we did the TOSA dialect, and that's a pretty similar, aimed at a pretty similar thing. And we did exactly profiles for that reason, for people to identify, is this something, that can be run on a class of device. So I think it's a useful thing. I could see the two, when we've talked with people, they found it a fairly interesting idea. I think I think in concept, it's quite good.
Mm-hmm.
I have a follow-up question. So in regarding to that, while you guys are implementing the TOSA device profile, did you think there's any experience that you would like to share with us?
Not really. I mean, we've taken a it's a fairly simplistic approach that we've taken. It's almost completely based on data types. I think with Stable HLO, there's a few ops that are obviously you're not going to want on an edge profile, like all the sharding and everything that, all the collective ops just are pretty obviously irrelevant. And then data types is likely going to be a key. You get down to things that don't have hard float, then you don't want to do float. That's kind of the area we've seen. So the three ways we broke it up were quantized int, inference, float inference, and training. So like you would bring the collectives probably only back for training, or at least the float version. But that's, you're free to obviously to decide your own axes to divide things up on.
Mm-hmm. Yeah, I think that makes sense. Yeah, like the other one we were wondering about, like another example is Stable HLO is quite permissive in terms of permitting n-dimensional tensors, and in terms of kind of folks building libraries to support all of that. That's an example of one of the things we're currently scratching our heads about, right? In terms of where to have an appropriate kind of functional boundary, so that we can, because like our ideal goal is that, you know, we would be able to, you know, have, you know, complete functionality for the set of things that are in the subset, right? But that to be as useful as possible. So that's another example that we're considering.
Yeah, we did max rank, and it can kind of vary. And then we did max size of tensor, or at least max per axis dimension. And I think we might have done a per total size per, you know, 32-bit versus 64-bit as a obvious kind of breaking point.
Yeah. Okay. That's kind of, yeah, good feedback. That's kind of useful.
I have a clarifying question. So if you go forward with these device profiles, right? Would they belong to the stable HLO spec or to TF Lite, or like basically no?
Yeah, we've also kind of thought that. I like, my bias would be to have something in the spec because it could be more useful, like, or to have a, yeah, my bias would be to try to do something with the community, because it would, yeah, it would be kind of clearer for others then to, who would have independent implementations that are not TF Lite, for example, would, you know, they could offer that or offer that minus a few things, you know, but at least it would be a clear understanding of what we regard as a complete set, right? Yeah, so that would be my bias, but again, like, I could imagine. Yeah, I can see valid reasons of having kind of supersets and subsets of the set that we would aim for, but I would also like to think the one we would do would be reasonably general purpose, or that would be our goal.
We also have some stable HO team dialing in as well as in the room. Do you guys have anything to add in regarding to that?
Slightly separate question. Going back to sort of where do we restrict this device profile? I feel like a pattern that I see happen is like transposing data and then calling a conv op just because you only support a certain kernel layout. Is that something that gets restricted in TOSA? Is there a limited kernel layout?
Yeah, we restrict it only to, probably get it wrong, but NHWC. We don't like, so you have to transpose NCHW to NHWC. It's a hassle, but most of them, generally you only have to do it on your input, and then anything in the middle generally folds away. Like if you're doing conv after conv. We've debated, should we have either chosen NCHW or allowed both? It's one I don't know that there's a right answer to. Like, it's a hassle to support more than one. So if it was easy to go back and do it, I don't know, it would be nice to have both flavors.
Yeah.
It would have been nice had PyTorch and TensorFlow way back when agreed on a common one, but that's unfortunately we can't fix that.
What does PyTorch do now with ExecuTorch? Have you guys looked at?
I don't know off the top of my head. We did work with the ExecuTorch. We have ExecuTorch to TOSA paths, but I wasn't directly working on the day-to-day, so I didn't. Oh no, I do know, because we went in and inserted the transposes at the front, and then we inserted them everywhere, and then folded all of the transpose pairs away.
So they're NCHW.
Yes.
On PyTorch.
Yeah, but as far as what gets supported under this broad stable HLO offset versus device specific profile, I think of it as can we canonicalize to the device specific profile as much as possible, and sort of have the canonical support device profile and then things that just aren't supported.
Mhm. Yeah, and I could see value in having some of that tooling being, part of the community as opposed to being in, part of the community project as opposed to being in a kind of product specific implementation, because I'm guessing that's going to be, it's going to be like a common, it'll be a kind of common problem that kind of anybody, picking this up for on device would need to solve. So that's the bias. But yeah, like I think this is all really good input, and I think we're going to think more about this ourselves, and and potentially propose something to the community in a few months, right? I think we're still working through getting we're at the beginning of kind of working through coverage, so it'll be a while before we get to the boundaries, but we do want to have we would love to have a kind of a completion goal that is set and fixed that we're kind of aiming for, and that we can kind of plan against. So yeah, we certainly I would imagine we would have something by the end of this year or very early in the new year, an initial proposal or RFC or something like that for consideration. Cool. One of the we could move on to the next discussion topic. And again, if anybody in the room has something they think is higher priority than what's on this slide, this is just stuff that is maybe kind of top of mind for our team, right? When I did a quick straw poll, but if anybody has something else, feel free to propose as well. So on the second bullet, right, for stable HLO on device, right, we firstly, I would kind of preface this by saying, right, there's lots that can be done for stable HLO to give great performance on a device without having composites in the picture, right? By using AOT compilation or by doing kind of kernel fusion in libraries, right? And we're pursuing both of those avenues is what I would say. But for for time to time, and some of those techniques will kind of take time, and from time to time there's something kind of business critical that you want maximum performance on, for example, attention kernels, and for there, manually specifying something like a composite up front is something we're experimenting with, where that would potentially flow through the framework as something like a user kernel or something annotated, but then we would get a composite for a more complex op, which we could then bind to a kind of a custom op, right? But the advantage of doing it via composites is there would still be a compatibility story, right? If we didn't have that kind of optimized implementation done on all devices. So that's an area we're exploring, right? Like I see, if we look around the industry, we see other folks, right? Like in NVIDIA's faster transformer library, or like with other vendors as well, having specialized custom kernels for some kind of transformer ops, because they know they can reliably optimize, and they can reliably optimize that more than perhaps what they're kind of getting in terms of elemental ops from a framework. So yeah, this is this is kind of something where we're also kind of experimenting with at the moment, right? But I was kind of wondering if anybody else in the room has any kind of thoughts on this topic, right? In terms of having like sets of kind of composites out there, and also available to provide an easier optimization path. If no, that's also okay. It's kind of one of the things we're kind of currently looking at. Finally, the last topic I had, and I'm not sure, Kevin, if quantization has been extensively, or anybody else in the room who's been at other sessions in the summit. I've been haven't been able to attend all of them, but I'm not sure if we've covered future quantization needs in depth in any other session. But from the perspective of on device, I think we've gotten to a point where we've a reasonable set of kind of quantization functionality. But I'm also aware there's other on device runtimes that support other you know, for example, kind of 4-bit blocked formats and things like this, which we which are not yet supported in stable HLO, for example, right? And yeah, kind of wondering if this is something that there's kind of wider community need, or if folks are kind of going up against this in their kind of implementations.
I would rephrase the question a little bit as well.
Yeah.
So,
Thanks.
we know that today the quantization scheme is designed to be mostly uniform quantization. I know there are other quantization scheme out there. So for the group here, is there any preference between the two? Do you think it's more is it more conform to use uniform quantization, or for example, GPTQ? Alternatively, the quantization types is incomplete in the spec just yet, right? Which quantization types do you guys think is higher priority? For example, int4 versus int8, the packing of the int4, is there any preference on that? And for example, sign versus unsigned, so on.
Yes, all of it, all the time. It's, I think the classic models, you know, the comms and stuff, you know, that's pretty well established at this point. It doesn't seem to be changing, but the llama models and the, you know, pretty much any of the LLMs people are coming up with new compression schemes all the time. I think that, you know, there's, and the packing gets weird, right? Like I4 is nice because you can at least assume that 2 nibbles make a byte. But then if you've got like I5 and multiple, you know, packed into some other thing with bit stealing and stuff, like this is what people are deploying. So, you know, got to do it. I think we've done this by just, you know, open coding the quantization transfer function for CPUs and GPUs before, you know, so do what they do when they're quantize exporting this. You know, usually you've got a CUDA kernel or something that is working on some greater multiple of an I32 type, and you know, then you just do the bit shifting and have the pattern for basically how to unpack it, because all these new things are unlike the previous generation, which was usually about you know, optimizing for specific compute hardware that had certain characteristics. Most of this in this generation is about just optimizing the data link path so that you can save memory bandwidth. So you're actually adding more compute usually in a generic implementation in order to save bandwidth. Not sure if that makes sense, but we haven't found a way to do it that isn't open coding the unpacking function.
Yeah, but it's challenging because in a lot of high performance implementations, folks want to, like, there's 2 approaches. You can have that unpacking being a pre-kernel, or more commonly for performance, you've kind of fused into the actual matmul kernel itself.
Oh yeah, you've got to fuse it minimally at the tile level, preferably at the register level.
Yeah, but yeah, so like the highest performant ones are fusing at the register level, and that kind of matters because if you were just doing it at the tile level, you potentially could have a custom call for unpack, you know. But if you want to do it at the register level, you would need to have, you know, completely specified in a way that a downstream compiler could digest, right?
Or fusion.
For fusion, yes, that's kind of where I was going. But then, yeah, there's challenges there because I don't know. I would assume, you know, the XLA offset today doesn't have bit packing and unpacking capabilities, right? For example, so it's
yeah, that's why we bypass stable HLO for all quantization today for LLMs.
Okay. Has anybody else come up against these kind of things? But yeah, and I think this is something we're also starting to look at for similar reasons, right?
I mean, there are there's if you've got a general purpose compiler, you see everything's a general purpose compiler problem, but there are an innumerable set of transfer functions that probably hit the hit a broad middle of some kind. I think it's just hard because everything's moving so fast.
Yeah. Yeah, it yeah, kind of yeah. Reminds me of texture compression. That's what I always think of this problem. And there's all sorts of crazy techniques for that too.
Yeah,
And people
exactly.
kind of standardize them, right? But yeah.
Yep. My gut tells me that maybe if you fast forwarded 4 years, you'd find a stable set. But right now it's we're in the whirlwind.
Mhm.
And you know how this goes, right? Like the first hand coded implementation that gets, hits the right adoption curve. It doesn't matter if it's better or worse, on certain hardware or whatnot. It just becomes the default.
Okay. Yep, clearly this is one for further study. Um,
Could you say a bit
any
more? Sorry, could you say a bit more about like what the quantization types, how you represent them for the parts where you bypass stable HLO? Is it upstream MLIR quant dialect stuff or?
We don't do quantization representations at all. We're just coming from PyTorch, which usually someone has specified a transfer function kernel, usually written in CUDA, that over a wider data type, and you just lower that. We lower it directly to 1alg.
Yeah, because practically there's a very small set of kernels that the unpacking is bound to, right? It can be like one or one, two, or three kernels.
Pick your favorite transposed matmul. Yeah, I just literally don't know at this point. I mean, I've been in quantization for a long time. This isn't really quantization. It's just people are going to keep pushing on, as long as we're memory bandwidth bound, people are going to keep pushing for weight compression schemes. And
any other kind of topics from the room or from folks on the bridge in terms of things that folks are wondering about in the space of on-device?
Basically, we're opening up the floor for any topics to discuss.
I'd like to come back to the composites talk just a little bit. Namely, the problem that keeps coming up is mobile runtime or some interpreted runtime or something of that nature. We need higher level constructs, stable HLO, too low level. I'm wondering if this is a problem that gets seen in TOSA or gets seen in Erie lowering, if there's any ways that have worked for solving it for these larger models.
It's something we're looking at. We've seen it. We've definitely seen it, like especially recently with the attention heads, but we don't have a solution yet. I mean, we can see the options. TOSA has a custom ops. You could always wrap it in that. You could look at other dialects like to wrap things in. We just haven't landed on what is the solution, but it definitely feels like one that we need to address. It's probably relatively constrained. It feels somewhat constrained, maybe, at the moment, but the next network will probably blow it all up again. So,
right.
Yeah, but interestingly though, you do see some networks being published that use, let's say, flash attention from Faster Transformer as that was actually used by the model authors from the very beginning, which is interesting because that then is less of a it doesn't put as much pressure on, like, the author is actually chosen to use a coarse-grained kernel outside of the framework, right? So yeah, like if yeah, like one could imagine a world where there's a kind of just a curated set of kind of composite type things that are also available at kernel altering time, right? And I know that would be kind of lagging because it would be lagging state of the art, but given that a lot of work is kind of, you know, there's a lot of advancements in the form of derivative work as well, right? So derivative work would be able to leverage the established set of things, right? Had we got an established set of things?
Yeah, I mean, there might be a different pacing on how this stuff evolves in the different frameworks. On PyTorch, there's not a conversation that like this that says should there be a faster transformer kernel. You know, it's a more organic thing, and then you've got to catch it. It's and you know it seems like it's just a lot quicker to ramp up to custom kernel, and so and you know to the point that you know we've kind of made the decision that if there's not a great custom op story, you know, in the lowerings that lets us solve the time to market thing, then it's you know that's how we prioritize. I don't know how you match that up against I just don't know how you match that up against these goals.
Yeah, like like I think the custom op is it's an easy way to go. I think the advantage of having it via composite is if you know, if you want to deploy it on runtimes which may not have that exact implementation, yeah, it's useful for like backwards compatibility, for example.
Yeah, but like at the PyTorch level, for example, you know any one of the export paths will have you specify your set of decompositions usually, and you know those are extensible and at the framework level, so you know and accessible by the users. So it's kind of not as it's the same effect, but there's not like this standardization debate. It's kind of if you can swallow the whole thing, you take it. Otherwise, you know it's pretty clear that it doesn't work, and you say decompose this up, and that's it. But it's very user driven.
But you still need to know that information prior to shipping it out to devices.
Yeah, I mean, you get the error.
Yeah.
Say make that op decomposed.
Yeah. And I thought it was interesting. The NVIDIA presentation yesterday made it sound like their short-term solution was let's try to make jacks emit very recognizable patterns for fused attention so that we can do pattern matching and fusing, standardizing it more at the framework level.
That was the position that the stable HLO forced them into, not their preferred position. Those pattern matches on that level are brutal.
Yeah, a lot of that was the driving work behind get the extensibility RFC and notion of composites. Provide a fast moving way for them to represent the high level abstractions where so long as this thing is semantically what they claim it to be, can pick it off and optimize without having to pattern match everything.
In regards of the pattern matching, of course, as we are talking about, this field is evolving rapidly. And I guess my question would be that, do you think it's possible for us to catch up just based on pattern matching? Because, or even like writing custom kernels at all, because custom high performance, I guess, require time to develop. And once it's there, the research community might move on to something else. Right. So yesterday, I think NVIDIA show off their scaled out product attention, but now the community start using a flash attention. We are kind of playing this catch up game. And do we see that this is the way to go, or maybe we can come up with something better? I don't know what it is.
And I don't have any answers. I will say that and especially at embedded and mobile, you know, because it's fragmented and kind of an air gap removed. But at the larger levels, if there's any control at all, you've custom, the custom kernel escape valve, making that easy and user accessible and basically invert the problem. There's 10 of you and 10,000 of them. It's a make the hardware somewhat programmable, and have a custom kernel language is what's happening above. So I don't know what you do when you convert that to below.
Yeah, and I think that's what makes the on-device, the air gap and the desire for backwards compatibility is why just doing the custom thing is a more challenging solution.
Like we should have a joke. It's not all bad. Maybe there's a don't boil the ocean, but just boil the teapot on the top, on the top or something. It's like these standardization of these offsets is laggy, and it takes a long time, but tends to provide good ballast in the ecosystem. But they're not super great at the high velocity leading edge stuff. And having a best, if there's a best of both worlds strategy that lets things eventually converge to sanity, that would be great. But in order to get the adoption, you've got to be able to embrace the differentiation that happens at the head of the pipe, I think. So I've always seen these reduction offsets as kind of robustly covering the 80%, and they make the core problem much easier. But then you've got to have a way to bridge the rest of it.
Yeah, I think that's fair, and I don't want to be all downbeat either, right? Like we're getting a heap of value out of having stable HLO as a fulcrum point between frameworks and getting new things running. Like so around compatibility and expressing functionality using a constrained set of things, like all of those things are going great, right? And these are the kind of the top of mind things at the moment, but I just kind of, just because we're sharing kind of top of mind problems doesn't mean there's other things that are actually going quite well and that we're quite happy with, right? It's just they're the less interesting things to talk about, is all. I don't know, John, we could adjourn a little early if folks have any other
Before
thoughts on
that,
any
I
other
guess
topics.
I don't want to ask you, is there any question in this room that's to the team or to Cormac? And we can share, we can go into detail on the parts of the updates, but otherwise, of course, we can adjourn early and have to lunch. All right.
Cool. Well,
Thanks.
thanks all for coming, right, and attending virtually or in person. And yeah, we'll, as we make any progress on these things, we'll certainly loop in the community as something as soon as we have something worth sharing, right? And yeah, it'd be great to get all of your feedback and contributions as we do.
Thank you, Cormac.
All right.